Come on, we will start with the next application of the Biot-Savart law to find out the magnetic field due to the current carrying loop or a coil at a point on the axis of the coil. Fine. Now you can see that suppose this is a coil, fine, with the center suppose O, and point P lies on an axial line or at the axis at a distance x with respect to the center. Suppose this is a radius A, and this distance, you can say this distance is taken as r. Fine. Now the current suppose flowing in the anti-clockwise direction. Now if I consider one line element or the current element, since current I is flowing here, so I say current element would be in this direction. Fine. Now current element, due to this current element, the magnetic field at a point P would be in which direction? That is, would be in this direction. See, how did you get this direction? With the help of right hand palm rule. Fine. With the right hand palm rule. Fine. Now see how the coil has been kept. See, the direction coil has been kept like this. The plane of the coil is kept like this. This P point lies here. Suppose this is an axis of the coil and P point lies here. You can see here. So P point lies here at a distance x. Fine. This is at distance x, and this distance is r. This distance is x. Fine. Now the current is flowing like this in this direction, in the anti-clockwise direction. So with the help of the palm rule, fine, you need to keep the thumb in the direction of the current. Fine, in the direction of the current, suppose. So you have to move your palm in such a fingers towards the palm. So what would be the direction of the magnetic field? It would be in this direction. You can see. Fine, the magnetic field would be in this direction, and this dB should be perpendicular to what? Perpendicular to ideal also, or perpendicular to position vector r also. Fine. So this is actually due to the Biot-Savart law. You have done this. dB is equal to mu naught upon 4 pi I dl cross r upon r square, or you can write mu naught upon 4 pi I dl cross r vector. See, this is r cap and this is r vector upon r square. Fine. So this dB must be perpendicular to ideal also and perpendicular to r also. We have done this in the cross product form. Fine. So here dB is perpendicular to r also, and in you can visualize in 3D. So ideal is also perpendicular to dB. 3 are mutually perpendicular to each other. Now suppose I make this one axis over here. Fine. Now if I say this angle is phi, we say this angle is 90 minus phi. Yes or no? Again you can see that this part is 90 degree. If this part is 90 minus phi, what do you say about this? This is phi. Suppose this is, so I say that this is 30 degree. So I can say this part is 60 degree. Okay, again this is 90 degree. If this is 60, what do you say about this? 30. Fine. So you can say that if this angle is phi, this angle is phi. So this dB is resolved in two components. One is dB cos phi and another is dB sin phi. Similarly, I take the diametrical opposite current element here also. Fine. So this is ideal and this is position vector r. So ideal, due to this ideal, the magnetic field at point P, again due to right hand palm rule, where should be the direction of B? Fine. The direction of B is in this direction. For this, direction of the magnetic field would be in this direction. So for this, the magnetic field would be in this direction. Now you can see that, so current is suppose flowing here. Fine. So you can see this current will go down. Fine. The current will go down. So where you will move your fingers? Towards the palm. So it would be in this direction. Fine. So magnetic field would be in this direction. Again due to symmetry, if this angle is phi, we say this angle is also phi. So this would be dB cos phi and this would be dB sin phi. Fine. Now you can see that according to the Biot-Savart law, the magnetic field due to any one of the current element is mu naught upon 4 pi I dl sin theta upon r square. Fine. So what is an angle between ideal and r? It is 90 degree. Fine. So they are mutually perpendicular to each other. It means that its angle is 90 degree. If this part is 90 degree, so dB is equal to mu naught upon 4 pi ideal upon r square. Similarly, it is applicable for this current element also. It means that dB is same for both this part. Fine. And cos component, you can say that cos phi is same. It means that this component cancel each other's effect. So total magnetic field at point P is only due to what? Sine component. So how you find out dB? dB sine phi ultimately will give you total B. But what is dB? dB is mu naught upon 4 pi I dl upon r square sine phi. Fine. Now sine phi, if you get from the geometry, suppose you consider this triangle. Fine. So what is sine phi? Sine phi is opposite side upon hypotenuse. So it will be A upon R. So I can replace sine phi as A upon R. So this would be ultimately mu naught upon 4 pi I dl upon r square into A upon R. Now which is a constant quantity? Take out that constant quantity out of integration. Mu naught I 4 pi r cube. Even r is constant because r is what? R is this distance. So this distance is not going to change. Fine. So A is again constant because it is a radius of the current carrying loop. So only the dl part will change. Fine. dl will go on changing for the whole ring. So integration would be, what would be the integration limit? From 0 to 2 pi a, whole circumference. So this would be what? Mu naught IA upon 4 pi r cube. Fine. Integration of 1 dl becomes L. Fine. So upper limit now minus lower limit. So mu naught IA upon 4 pi r cube into 2 pi a minus 0. Upper limit minus lower limit. You can see that this 2 pi goes away. So this becomes mu naught I a square upon 2r cube. So this is the total magnetic field. You can replace r square in such a way from the geometry. You can see that this is 90 degree again. Fine. This is 90 degree. Why it is 90 degree? Because the coil is kept like this. Fine. So this makes a 90 degree with this axis. Fine. So it is 90 degree. So can I write a square plus x square is equal to r square? Fine. A square plus x square is equal to r square. Therefore r is equal to a square plus x square raised to 1 by 2. If I want cube, so I take the cube on both the sides. So this equation becomes a square plus x square raised to 3 by 2. So replace x cube from in this equation as mu naught I a square upon 2 a square plus x square raised to 3 by 2. So this is a required answer. Now if you need to find out magnetic field at the center, if the magnetic field at the center is to be find out, that means P is replaced here. Means P has been brought at 0. It means that x becomes 0. So you can put here x is equal to 0. Fine. So you will get the equation B at center also as a case, that is equal to what? Mu naught I a square upon 2 a square, x will go away. So that would be 3 by 2. So ultimately this becomes what? Mu naught I upon 2a. Fine. I hope you understand this. Fine.